Okay, so today we're going to continue talking about the female reproductive system. When we left off, we were talking about the ovarian cycle. Okay, so just to set us up and remind us where we're coming from, I'm going to ask you a couple questions. So the reproductive tract that we're talking about today, the female reproductive tract, we talked at the beginning of our reproductive section about development of male and female reproductive structures. So where was it that that female reproductive tract was coming from? Okay, take another second. All right, great. Yeah, so early in embryonic life, we have two options for pathways. We have our Wolffian duct and our Mullerian duct. And to end up with a typical female reproductive tract, all that needs to happen is nothing. We just need to not have an SRY gene and not have testosterone start to develop out of the testes. So if that's the case, we're going to end up with a Mullerian tract and the Wolffian duct degenerates. Whereas if we do have an SRY gene, that means we have testes developing, we start producing testosterone as well as the Mullerian inhibiting hormone, which is how we end up with the male reproductive system. Great. Okay. So we were also talking about the maturation of follicles and gametes. So let's recall back to what's going on with meiosis. So when we're producing our haploid gametes, getting them ready for fertilization, we need to go through meiosis. So we traced through last time what that looks like in the male reproductive system as we're developing sperm. We also took a look at a comparison of what's going on with our egg cells. So there were some similarities and some differences. A lot of it had to do with timing. So which of these are true? Okay, take another second or two. All right, let's take a look. Okay, cool. Yeah, so we got that first part, which is great because that's where we've been most of this time. So we all know, or many of us know already, that we're setting up for meiosis during fetal life. So before you are born, your chromosomes duplicate and get ready to start meiosis. Then we go into that meiotic arrest period. So yes, very true. Meiosis and gamete production does end in the female reproductive development. So we can no longer mature ova and mature oocytes after menopause. So while we can create functional sperm throughout the lifespan in the male reproductive system, not so in the female. The other thing that's true is this last one, ending after fertilization. So we have to come back out of meiotic arrest to resume meiosis and do that first part of division, that meiosis 1. And that's starting up right before ovulation. So ovulation then occurs, and we don't finish up with meiosis 2, that second phase of meiosis, until after fertilization. So both of those are actually true. Okay. So reviewing where we were for the ovarian cycle. So we have that ovum that's developing inside a follicle. And then we ended it at about ovulation, but that's when we have the follicle turning into this glandular structure that then degenerates unless fertilization occurs. So we started with that follicular phase, the first half, about 14 days, was from the beginning of menstruation, so the first day of someone's period, until ovulation. And then the luteal phase is the second half, running right until menstruation begins again when we loop back. And so we saw a variety of structures developing during that follicular phase, and then degenerating during the luteal phase. So we saw that we were starting out with a primordial follicle. So we have one oocyte developing, surrounded by a layer of follicle cells. We have multiple primordial follicles kicking off their development during every 28-day cycle. We just pick a handful of them, not all of them, but not just one of them. So they develop. As they grow, those follicle cells split out and give us some new types of cells, one of which are our granulosa cells that we can see here surrounding that oocyte. We can see that some of these other layers are separating out here as well. So some of the granulosa cells are giving us zona pellucida cells and theca cells, other types of cells in that follicle surrounding and supporting the growth of the oocyte. As we move forward, if you go from, basically we have steps of how big this follicle is, right? So we start with a primordial follicle, and then a primary follicle, we've started to grow a bit. Secondary follicle, we develop this structure called the antrum. So the antrum is this sac of fluid that we can see here in amongst those granulosa cells. Okay. So those granulosa cells are continuing to develop as we get to our mature Graafian follicle. So here's that Graafian follicle. So we can see that the granulosa cells have given us a kind of crown-like structure surrounding our growing oocyte. So that's our corona radiata. And particularly, we can see that this antrum has gotten quite large in our Graafian follicle, which is the mature follicle. So as we move towards ovulation, what happens now is in that Graafian follicle, right before ovulation, that's when we have meiosis 1 occurring. So we actually have the first split of our cells in terms of splitting up genetic information. We don't end up with a second gamete, a second functional cell at this point, because when we produce female gametes, we get like a kind of unequal divide of the cellular like machinery. So we end up with like splitting off like a tiny polar body that we don't think about basically. Okay. So we do meiosis 1. And then at the very end of this follicular phase, we see a spike in hormones that leads to triggering ovulation. This is around day 14. So this antrum is going to burst when we have the surge in LH. Whoop. And that leads us into the luteal phase, where we have this corpus luteum forming and then degenerating, coming from all these like granulosa cells and other kind of cells that have been differentiating around the oocyte. Okay. So we have GnRH spike, and then we have LH spike in response, and it's that LH spike triggering this. So that's just a different format of what we spoke about last time. Okay. So at the same time as we have our ovarian cycle happening, we have a uterine cycle happening. So we've got these two things running along kind of in parallel. We think about them separately, one, because they're two different organs, but also because we're going to see that while the ovarian cycle just has two phases, the follicular and the luteal, so that's our ovarian cycle over here, our uterine cycle has three phases. So we got to match them up a little different. Okay. So when we think about our uterine cycle, we're going to start with a menstrual phase for the first 5 or so days. Then we're going to head into a proliferative phase, which is going to happen up to day 14. So from the end of menstruation up until ovulation, we're going to have this proliferative phase ongoing. And then the final phase of the uterine cycle is the secretory phase from days 15 to 28. And that matches up with the timing of the luteal phase here. Okay. So basically we have unequal divisions in the uterine cycle. During our ovarian cycle, we were just splitting half and half, follicular and luteal. During the uterine cycle, the secretory phase is just as long as the luteal phase is at the end there. But during this follicular phase, we have two separate things going on, whether we're talking about the beginning in that menstrual phase or this non-menstrual portion, the proliferative phase. Okay, so we're going to take a look at those. All right, so the beginning of the uterine cycle is matching up with day 1 of menstruation. So this is also day 1 in the ovarian cycle of that follicular phase. Okay. And what's happening during the menstrual phase is that we are shedding the lining of the uterus. So the uterus has different layers to it. So it's got a lot of muscle. It is a muscle basically, but it also has an inner lining. It also has blood flow within it. It also has glands within it, and it builds up and loses tissue on a kind of like cyclical basis. So the menstrual phase, at the beginning of the cycle, it's shedding up the uterine lining that it forms during the previous cycle, basically to start over. Okay. So what's happening here is we can see this lining here shown in kind of red that we have built up later on during these later phases. Okay. And at the beginning of menstruation, we have the blood flow to that tissue decreasing, which means that that inner layer of tissue kind of dies off. And as it dies off, it kind of falls off the walls of the uterus, right? So then we've got it kind of hanging around in the uterus. And then it moves through the uterus, right? We've got like basically gravity, but also some uterine contractions that push or pull or let descend that tissue through the cervix and into the vagina, out of the body. That's what the menstrual flow is. It's getting rid of this internal tissue here so that we can start over, and because we don't currently have the blood flow to support it. Okay. Menstruation is triggered by hormones, okay? So this is under hormonal control. This doesn't happen just at random. This doesn't happen because the moon said so. It happens because we have a decreased level of estrogen and progesterone as we are entering the menstrual phase. So if we think back to the ovarian cycle, the second half of the ovarian cycle is the luteal phase. And the point of the luteal phase is that we made this corpus luteum, this gland that's producing estrogen and progesterone during that second half of the ovarian cycle. But as it starts to die away, which it does because the luteal phase only lasts for about 2 weeks, as it dies away, we're going to see these hormone levels dropping because we're losing a gland that was producing them. So it's that lack of hormones, that kind of like withdrawal from the hormones that is producing menstruation. All right, so that's our like signal that we need to start the cycle over. Because if fertilization does occur, that gland gets maintained, and we see continued production of hormones, which are eventually some of them taken over by the placenta. We have a whole suite of structures that kind of arise and do their own thing during pregnancy. So this gland degenerating means fertilization has not occurred, which means we have a drop in hormones. So your body's starting over. So menstruation, we've got this lining coming off. These blood vessels have kind of pulled back, died off a little bit. So that's for the first 5 or so days of the cycle. Once we have that whole lining off, we're going to enter the proliferative phase around day 5. So menstruation is typically ballparked at about 5 days. Okay. So during the proliferative phase, we're starting over again. And ultimately what we're doing, right, is ovulation is occurring at day 14 from the ovaries. So we're starting to set up for the possibility that fertilization might occur. We might end up with a fertilized ovule coming into the uterus and trying to implant at the end of the proliferative phase. So the uterus is preparing a nice happy home for that possible fertilized ovum. So what we're doing is we're going to regrow our lining. So we're going to grow and thicken both the endometrial lining. So we're producing a lining in the center. So like the center of the uterus would be like up here. We're just looking at the wall. So we're producing a lining, and we're also growing the layer of the endometrium in general. So the thickness of the tissue, even the part that we're going to keep in our bodies, is thickening. We're going to have glands in the walls of the uterus, in that endometrium, that are going to get larger during this proliferative phase. We're also going to thicken up our smooth muscle layer during the proliferative phase, getting ready to potentially do some muscular contractions. And down at the cervix, which is actually really the bottom third of the uterus or so, it just kind of projects into the vagina. We have other glands, so cervical glands specifically, and they're going to start secreting mucus. So they're going to start changing like the physical and chemical properties of the aqueous environment at that entrance to the uterus. So we're going to start to see mucus down at the bottom of the uterus, at that kind of segment between the vagina and the body of the uterus. Okay. So the reason this is happening from a hormonal perspective is really estrogen. So we have an estrogen signal coming. It's related to the development of those follicles in the ovary. So all this estrogen that we're producing at that point is telling us to develop this uterine lining, triggering all these changes inside the uterus. Then we go into the secretory phase around about day 14. Okay, so at the secretory phase, this is starting right after ovulation, basically. Now, when ovulation occurs, your body knows ovulation occurred, doesn't know for like a little while as to whether a egg has been fertilized or not, because that egg cell has to basically come down the pipes and implant, even if it has been fertilized. So during this secretory phase, we're really kind of continuing the development of structures that would support a potential pregnancy, basically. So the endometrium is going to continue to prepare for implantation. So we saw it growing thicker. We saw the glands enlarging during the proliferative phase. That's kind of continuing here. But what we can especially notice during the secretory phase is that we have all these blood vessels. This blood supply is increasing because if we have a fertilized ovum implant, we're going to need to give it blood flow, as well as we're going to need to get blood flow to produce things like a placenta. We're going to need to do a lot of stuff if we do happen to have a fertilized egg implant. The glands that we've been building larger during the proliferative phase, they're going to continue to get bigger, and they're going to start to secrete fluids rich in glycogen. So remembering glycogen is basically a bunch of glucose monomers stuck together. So what we're doing when we start secreting this glycogen-rich fluid is we're giving anything in that environment inside the uterus a quick, rapid source of energy, right? So we're basically putting in a bunch of sugars there that could be broken down to produce ATP. At the same time, in the cervix, before we were creating a kind of like thinner cervical mucus. So the mucus that we secrete during the proliferative phase before ovulation is kind of thin and conducive to sperm swimming through it, basically. Whereas during the secretory phase, now that we're nearing the end of this cycle, fertilization either happened or didn't happen. So what we're going to do is kind of like try to close the door to the uterus on the off chance we do have a fertilized egg implant. So the secretions from the cervix are now going to be this kind of like sticky plug that we're forming, basically, so that if we do have a fertilized egg implant in the wall of the uterus, we don't have like any pathogens or anything coming in from the outside world. And that uterus is kind of like closed off and protected for potential embryonic and fetal development. So we'd see a difference in like color and texture of cervical secretions during this secretory phase during this time. So here's how we would pair up in images the days of a typical cycle with the ovarian phases, both in terms of what they're called and what's going on in picture form here, as well as what's going on in the uterus at the same time. So we see here, follicular phase, beginning of it, we've got menstruation in the uterus, first 5 days or so. We've got blood coming off the walls of the uterus. That blood is really the lining of the uterus. So we've got some tissue coming out of the body as these little primordial follicles are growing into primary, secondary, and then Graafian follicles. Okay, so that menstrual phase is first. And those sort of larger follicles are going to be associated with the proliferative phase. So as the follicles are producing estrogen for us, we're going to see the growth of this endometrial lining and this endometrial thickness. We're going to see glands enlarging. And then we're going to hit ovulation. So this separation between the follicular phase and the luteal phase around day 14, where we release an egg cell. Okay. So at that point, we flip into the secretory phase in the uterus and fully prepare that uterus to receive a fertilized egg for implantation. So we see those glands making the glycogen-rich fluid. We see extra blood flow in the walls of the uterus. We see a cervical plug forming. And from the ovaries perspective, we've let go of that egg cell. We've let go of our oocyte. It's on its way. It's doing whatever it's doing. And the tissue that is left here in the ovary is turning into that corpus luteum, producing estrogens and progesterone for a little while until it degenerates, at which point we see a drop in the body of estrogens and progesterone. So we don't have them coming from this corpus luteum, and we don't have follicles making them yet either. So we've got this like withdrawal triggering us to go back to menstruation here at the end. So that's how it like links together. We could also link it together and identify some of these phases by looking at hormone levels themselves. Okay. So in terms of hormonal changes during the menstrual cycle, we can look either or both at sex hormones or at hormones that are basically communicating with your brain, right? Okay. So here up at the top, we're looking at plasma levels of estrogen and progesterone. So we can see that if we track estrogen, we have a rise in estrogen kind of later in the follicular phase, then it drops, and then it rises again, kind of partway through the luteal phase, then drops again. For progesterone, we see that we have really no progesterone being released during the first half of the cycle. So no progesterone during the follicular phase. But during the luteal phase, we have a rise in progesterone and then a drop. Okay. And so what's going on with these is that we are secreting them from different places, the estrogen and the progesterone. So the estrogen is coming first during that follicular phase. The reason we have a rise in estrogen but not in progesterone is that those developing follicles, so those follicles where we have an egg cell growing, maybe to get to ovulation, maybe to be released, they are producing estrogen. So as we have several primordial follicles turning into primary and secondary follicles, eventually producing a dominant follicle, the other one's kind of dying away. They're all making us some estrogen. So that's what we see explaining this first rise in estrogen. But follicles don't make progesterone, so there isn't any. During the luteal phase, so the second half, we see progesterone on the rise basically just after ovulation. So this is because the corpus luteum does make progesterone. So the corpus luteum makes both progesterone and estrogen, which is why we see both of them coming up here. So it's a little stronger on that progesterone signal, actually. Right? So it's making like a lot of progesterone, but it's also making us some estrogen. Okay? So if we look at estrogen and progesterone levels, we would really be able to tell apart these two halves of our ovarian cycle. Because if we have estrogen and no progesterone, for sure this is follicular phase. For in the luteal phase, we would expect to see levels of both of these. And if we're dropping way down to the bottom, not really on this figure, but if we have really low levels of both, we would expect that this is triggering menstruation and we're entering this first part of our follicular phase. Okay, so those are the sex hormones. We also have pituitary hormones coming from that anterior part of the pituitary, connected up to the hypothalamus, involved in this picture. Okay. So the anterior part of the pituitary was the one that had all those very many signaling hormones. We are now coming back to one that we didn't talk about that much when we talked about our hypothalamic pituitary axes, but they're super important for the reproductive system. Okay, so we have our hormones, luteinizing hormone and follicle stimulating hormone, coming from that anterior pituitary. So if we're looking at them during the follicular phase, they're, let's call them low. They're low-ish for most of the follicular phase. And then if you look at their peaks, we've got this super sharp rise, right? Crazy sharp rise. They're responding to gonadotropin releasing hormone from the hypothalamus. We see this sharp peak. So here's our LH peak up top and our FSH peak kind of running along with that. And if you look closely, you'll see that the tippy top of that peak is right before our dotted line marking ovulation. So this is the trigger for ovulation. As soon as this happens, the Graafian follicle and its antrum burst and the egg cell is released. And that's really the point of these hormone surges here. Okay. So these are peaking. Boom, we release the egg. So the rest of that follicle is sticking around and becoming the corpus luteum, producing progesterone and estrogen, okay? Which is part of why we see this drop way back down in LH and FSH, because estrogens and progesterone inhibit the secretion of LH and FSH. So you can imagine that if we didn't have the corpus luteum making this estrogen and progesterone, maybe we'd stay like way up here for LH and FSH levels, but we've got like this negative feedback coming from the corpus luteum telling us pull it way back down. So we end up just seeing this one little spike here. So if you ever see it like Walgreens or something, like ovulation detector kits, this is actually what they're testing for. They're testing for this LH spike. This is like a really dramatic spike, so a potentially testable one if you're trying to figure out ovulation phases or timing. Okay. So here we have a flow chart of what's happening with hormones early in the follicular phase through like the midpoint or so of the follicular phase. Okay, so this is figuring out like how are we getting to the point of developing these structures surrounding the egg, developing that oocyte and triggering ovulation. Okay. So from the hypothalamus, we're secreting some gonadotropin releasing hormone up top, okay? And that's going to be like kind of our initial stimulus right here. We've got that portal system, that communicating capillary bed connecting us up to the anterior pituitary. I suppose I should say down to the anterior pituitary, since that's more of the correct anatomical direction. But anyway, from the hypothalamus, we're going into the pituitary. And that increase in the gonadotropin releasing hormone, the GnRH, is telling us to make FSH and make LH. Okay, so far so good. That's where these hormones are coming from. And then we got to think about how that's interacting with what's going on in the follicles that are developing in the ovary. Okay, so for let's try the FSH first. Okay. So for the FSH, the follicle stimulating hormone, down in the ovary, what it's coming into contact with are the granulosa cells. So those were the cells that were drawn kind of in beige, surrounding and supporting development of the oocyte. Okay. And those granulosa cells are going to be releasing some inhibin in response to all this, which is going to be a little bit of a negative feedback loop on that FSH. So those developing granulosa cells are kind of keeping that FSH level down. Now, this is early to mid follicular phase, so this is okay. This is because we don't want the spike yet, basically. The spike is a trigger for ovulation. So this is part of how we're keeping that spike from happening too soon. Bless you. Okay. So the other thing that is happening with the FSH in the granulosa cells is that the FSH is telling those granulosa cells to continue developing that follicle, continue to provide nutrients to that developing oocyte, continue growing it. We want to prepare it for ovulation. So we're having meiosis 1 occur right before ovulation. So that step of oogenesis is happening during the follicular phase. So the FSH signal is telling us all about that. Okay. Now let's go back to the LH side. So the LH, the luteinizing hormone, is the other hormone coming from the anterior pituitary that's involved in this picture. So the luteinizing hormone, one place it's going, really interesting. So it's got like a pit stop at the theca cells. So these are some of the specialized follicular cells that we see in some of those later types of follicles as they're growing. And it's actually telling the theca cells to make some androgens, so like testosterone. So we actually secrete some of those androgens in response to LH, even in the female reproductive cycle. And part of why we do that is that androgens can actually be enzymatically modified into estrogen. So like we can turn androgens into estrogen, and that's what we actually do. So the LH tells the theca cells to make some androgens, which we then turn into estrogens, basically at the level of the granulosa cells, which continue to tell that follicle to develop, tell meiosis 1 to happen. So this estrogen secretion is increasing. This means that estrogen also gets into your bloodstream. So estrogen ends up in the blood plasma. And this is a negative feedback loop on LH and on the original signal coming from the hypothalamus. So we've got multiple levels of this negative feedback loop from estrogen. And the big point of that, right, is that while we're still developing these follicles, we don't want our LH surge to happen yet. We don't want the FSH surge to happen yet. We're keeping those levels down so that we can have a really marked spike triggering ovulation. So until those cells are ready and developed enough for us to have a good functional egg cell released from a mature follicle, these negative feedback loops keep the levels of these hormones from the anterior pituitary down. So here is a little bit of a rundown of what's going on with the many actions of estrogens. So we have estrogens during a lot of the cycle coming from different places, right? So we have different things that they're responsible for during the follicular phase versus during the luteal phase and potentially during pregnancy. So what we've just been tracing through is one of their big important jobs is to promote follicle development and the maturation of those oocytes, triggering that meiosis 1. In the uterus, they're telling the endometrium to grow, right? Because we're setting up for the secretory phase. So they're promoting endometrial growth during that proliferative phase of the uterine cycle. And here we see what is happening relative to some other hormones. So we have estrogen acting on LH receptors, we have it acting on progesterone receptors in the uterus, as well as on secretion of LH at all, happening kind of in that follicular phase. And then during the luteal phase or during pregnancy, we'd see a much different kind of role of these estrogens. So if we move forward in time, we either end up with a fertilized egg, or maybe your body just doesn't know and you're just kind of in the luteal phase early on in that. Estrogens are going to do things like promote the growth of ducts and fat in the breasts, kind of preparing them eventually for lactation. So they're promoting the growth of those tissues, but early in pregnancy or during the luteal phase, obviously it's not time to actually lactate yet. So at the same time, they're going to suppress the actual lactation itself, just grow the tissue. So they are going to have effects on the secretion of something called prolactin. They're going to have effects on contractile activity of the uterus. They're going to have effects on oxytocin receptors in the uterus. And they're going to promote the retention of fluids, actually. So keeping like extra volume of like water and hydration in the body, either during pregnancy or during this luteal phase, kind of holding on to it there. So during the late follicular phase, we see a change in basically what estrogen does in the body. Okay, so early in the follicular phase, the estrogen present was doing a negative feedback kind of action on LH and on GnRH, right? So all of this was about suppressing early and into the mid follicular phase. But as we move into the later follicular phase, these different kind of like concentrations and compositions of estrogens actually have a positive feedback loop effect here. So we almost almost never talk about positive feedback loops, right? Whenever we're thinking negative versus positive feedback, our best guess is probably negative feedback. That happens all the time in homeostasis, right? Because we're trying to maintain a set level. But when we're thinking about the release of an egg cell during ovulation, that's like one of two times where positive feedback is really, really important from the physiology perspective, from the perspective of this course. So the other place positive feedback is really important is clotting, producing blood clot. We really want to make a blood clot bigger and bigger. Now that we're in the reproductive system, late in the follicular phase, we want a surge in LH. We want that spike of that hormone so that ovulation occurs. So we see that later in the follicular phase, as those granulosa cells secrete estrogen, it's not suppressing the LH anymore. Instead, those levels of estrogen are raising up the levels of LH and FSH secretion, as well as telling the hypothalamus to send more and more and more of its signal, GnRH. And this is what causes that sharp spike here. So it's the maturing follicle. We now have like a dominant follicle. We're moving into that mature Graafian follicle. And all that estrogen secreted from the granulosa cells of that more mature follicle have this kind of different effect. Right. So that leads to the spike, which leads to ovulation. So release of the ovulation, release of the egg cell. As we release that egg cell, everything that remains of that follicle is turning into the corpus luteum, right? So we're turning into this glandular structure that is now producing estrogen again, but also progesterone, which we haven't seen yet from the perspective of our ovarian cycle. So progesterone doesn't show up until after ovulation, until we're in the luteal phase itself. So what progesterone is doing is it's going to move us into the secretory phase of the uterus. So it's going to tell us to change the composition of the fluids and mucus coming from endometrial glands and the cervix. It's going to, for a little while, suppress our uterine contractile activity. We want to have this nice, stable environment. It's also going to be promoting the growth of glandular tissue in the breasts and suppressing milk production. Unless pregnancy occurs, and then we'll see all these hormone levels like continue and kind of shift further on as well. So in the luteal phase, we're thinking about more hormones than before. So we're still thinking gonadotropin releasing hormone from the hypothalamus. The anterior pituitary is still making FSH, still making LH, but we have these negative feedback loops back. So this is going to be really important, is that the corpus luteum is secreting some inhibin. So that inhibits FSH. It's secreting progesterone, which double extra suppresses LH. So we're pulling all of our spike back down, basically with those two negative feedback loops. It's secreting a little bit of estrogen, but lower than the levels that we were seeing in the late follicular phase. So we're not really thinking about those lower amounts of estrogen at the beginning of the luteal phase as doing much in particular at that point. Okay, so we're pulling back down the LH surge with that inhibin and largely with that progesterone coming from the corpus luteum. So that's what's going on during every 28-day cycle. But we do have also like long-term regulation of reproductive function, right? So not just in the timeline of 28 days, but in the timeline of life, okay? So estrogen is partially responsible for that. So these estrogen levels being produced by maturing ovaries and maturing follicles and hormonal shifts more generally are producing the secondary sex characteristics typical in females. So estrogens during puberty are part of the signal that creates widening of the hips, as well as deposition of fat tissue in the breasts and the hips and the butt. Also changes qualities of the skin. So we see changes to skin oils, as well as changes to body hair. So basically production of body hair in those secondary sex characteristic regions. And we see the growth of bones also partially a response to this increased production of estrogen during this portion of development. Over the course of the functional reproductive years, we're going to see that estrogen levels in females are going to stay high. So we do have some ebb and flow because of the ovarian cycle and the different actions of estrogen. But if we're just like kind of averaging it out over the years, we're going to see that estrogen levels are staying way up above baseline, even despite those fluctuations. This is part of what's maintaining all of these secondary sexual characteristics, right? So they're basically keeping these features prominent during reproductive years. Now, during menopause, estrogen levels are decreasing as we are no longer really producing follicles that grow and develop and then ovulate and then regenerate, right? So during menopause, that cycling basically stops because eventually you run out of follicles because we started out with the full number of them that we have available at birth, right? So you run out because those developing follicles are really part of our source of estrogen. Once they're no longer doing that, once there are no longer as many of them, estrogen levels are going to kind of subside. So this has a number of impacts on what people feel in their lives, as well as some of those secondary sexual characteristics. So this is part of why we see like changes to body shape during menopause. It's also probably part of the trigger for common symptoms like hot flashes, as well as changes to the risk of heart disease and osteoporosis that aren't really all that common in females during the reproductive years, but do become more common after menopause. Okay, so we are going to pause there for today. We'll pick up talking a little bit more about some of the impacts on patients and life choices